Today we're going to be covering the blog post tutorial on the Isovalent.com website, setting up a cybersecurity honeypot with Tetragon to trigger Canary tokens. So in my lab today, I've already got Cilium installed, just so that we can run a couple of containers, and I've also got a demo app installed as well. That demo app is the same as the application that we take you through in the tutorial itself. So if I get pods in the namespace of demo app, we can see that installed there. And essentially, I'm just going to walk through pretty much the same information that's in this blog post as well, but now you can see some of those actions happen in real time. So the first thing that I want to do is I want to get Tetragon installed. So if you go to the tetragon.io website, you'll see that thanks to our team working behind the scenes here in the open source community, and the fact that we've also released the 1.0 release of Tetragon as well. We've had a little bit of an overhaul as well of that page. For those of you that haven't come across Tetragon before, it's an eBPF-based security, observability, and runtime enforcement tool. It's also Kubernetes aware, so it can match with Kubernetes data, as you're going to see some of the examples that I show you. And essentially, Tetragon allows you to create policies and filtering using eBPF at the kernel level. This allows for reduced overhead, tracking of processes, and real-time enforcement of those policies as well at the kernel level. So I'm going to click into the documentation here. And again, we've given our documentation a great overhaul with that 1.0 release. I'm going to go to the installation. I'm going to deploy onto Kubernetes, but as you can see here, we've got a number of ways that you can deploy Tetragon. It's not just for Kubernetes environments as well. You can actually just install it on a normal Linux server, which I think is really, really cool. So deploy here, and I'm just going to take these commands. And I'm going to go back into my lab. I'm going to install that. And I'm just going to wait for that rollout to complete as well. Okay, so that's up and running. And basically that's all you need to get Tetragon working. From here on out, it's just creating policies going forward. I'm going to show you an example policy today, but if I just go back to the documentation page here, you can actually learn about the concepts of Tetragon, how policies work, for example, as well. And we also have a policy library available to take you through various examples. I'm just going to click on policies here under the concepts heading. And essentially, we can teach you the basics of a trace policy using an example. We can also, a policy essentially is based around two areas. The first one is a hook point. So this is what we're pulling from the kernel, where we hook into the kernel to get the data that we need. And then the selectors is the filtering of that information that comes from the kernel level, and then what actions we want to take from that as well. If you are installing this in a Kubernetes environment, because we are aware of that Kubernetes-based metadata, it means we can also do some really cool things such as pod filtering and namespace filtering as well. So the policy that I'm going to apply today is just kind of a cluster wide policy, but if I wanted, I could actually just pass that directly to the namespace as well. So it's not monitoring other workloads that happen in other environments. Other namespaces of my environment as well. So because I want to use a Canary token, for those of you that aren't aware, a Canary token is a cybersecurity terminology used for either a virtual or physical device, which could represent something that it's kind of not within your environment. So that could be a router, it could be a file share, it could be an image. And the idea here is it's there to be triggered when someone tries to access it that typically wouldn't be accessing that component. So in our environment here, what we're actually going to do is reverse that a little bit away and use it at the Canary token as an alert engine when we found an event that we know shouldn't happen in the environment. So we're going to capture this when someone tried to change our password file in the etc directory within our container. So Canary tokens were created by a company called Thinkst, and thinks to have actually created this free website called canarytokens.org, and it'll take you to the generate page by default, and then you can generate a canary token that you can use free of charge. So we've got a number of them available today. We're just going to use the URL token because we're just going to call to that URL when we've triggered our pulsar. So on here, I'm just going to type Tetragon at isovalent.com. This is for the Tetragon Canary video. Oh, and I'm going to click create my canary, and then we're going to get this web token available. So in my environment, go back to my lab, I'm going to do vi tracy pulsar. And what I've done here is using the example pulses that are available. So if we go here, we've got a couple of available in our policy library. For you to use today, I'm using the file observability policies so that I can see executions going on within a particular location. So here we're looking for the kernel probe of security file permission. We're looking to the path that has been used, and then we're equaling that path to our etc password file. And we're looking for the type of instruction to be either read or write against that as well. And then you can see here at the end, we've got this match actions as well. So if I just go to URL on this line, and if we delete that, I'll go back to my canary tokens. I'm going to copy this. I'm going to paste this, and I'm going to save that as well. And now I'm just going to apply that into my environment. And then what I'm also going to do in my second terminal here so that you can see the live information coming through, we're going to see in Tetragon, we're also going to see trigger on the Canary Tokens website as well. So now what I'm going to do is I'm just going to pipe some information into my etc password file. So someone's trying to either change that or modify it in some way. It maybe could be ransomware coming to my environment and modifying those files as well. So if I just run the exec command, and basically we're just going to echo something into that password file that returns. And if I go to terminal 2 here, we can now see that we've got a compacted output, which is a process executing something strange. And then we can see the exit there as well. But we also get this as a full JSON format if we wanted. And again, the Tetragon documentation will take you through that. And the last thing I'm going to do inside of my environment, that terminal, is I'm just going to get a curl on here so we can see my public IP address is ends in 196.36, and again, because we're running this on the same node where I'm running my Kubernetes environment, we'll all see that canary token. So if I go back to my canary token now, and I go to manage this token, and then we can see here this token has been triggered once, and if I want to view its history, we can now see where it's been triggered from. So this, it's running from a data center in Brussels where this machine is. And we can see here that we've triggered from that IP address as well. So we can see the information about there. We can see that this isn't a known exit node where this has been triggered from at the moment. So we've got a number of kind of pieces of information that are coming from the Canary tracking itself. But that's it. Really, really simple in how to use Tetragon to trigger to another alerting system when we found that kernel level event going on. So some of the other areas that you may want to use this in the future in terms of Honeypot is maybe you want to create like an SSH file that you place inside of your containers or your Linux machines that you know is not used by anyone or any applications, for example. But as soon as someone reads that or tries to access it, you then use Tetragon to trigger that alert as a kind of honeypot, because it's like, hey, that file should not be used by anyone. So we know if someone's trying to access it, then either it's with malicious intent or potential misconfiguration as well. And that wraps our really quick video on that. Thank you very much.